First, we have John Dougherty from Munich, who's going to be talking about a topic that might be covered quite a bit this morning, pragmatism and the interpretation of physical theories.
Thanks, Adam, and thank you to the organizers for putting together this awesome workshop and for letting me be a part of it. As Adam said, I want to talk about some stuff in the interpretation of physical theories and some pragmatist influences on what I take to be sort of part of the history of the way this debate has gone. So the place that I want to start is with some recent dissatisfactions in philosophy of physics, and in particular in philosophy of quantum field theory. So there was a kind of view that was relatively widespread and may still be, which is that, well, when you go and you try to learn quantum field theory, what you find is that it's mathematically messy in various ways that some people take to be different from other theories. And this prevents philosophers of physics from applying the sort of broadly acceptable hermeneutic strategies to quantum field theory that they apply to other physical theories. And this attitude is pretty well expressed by Hans Halvorsen in this handbook article he wrote with Michael Luger. So he says, in the absence of some sort of mathematically intelligible description of QFT, the philosopher of physics has two options. You can either find a new way to understand the task of interpretation, or remain silent about the interpretation of quantum field theory unless and until mathematical physicists get their act together. And you know, broadly speaking, for a while, many people thought, well, let's go with the second one, right? There are projects in mathematical physics to try to rigorize quantum field theory. Why don't we just wait until they do it? After all, we're philosophers, not mathematicians. Let the mathematicians do the mathematics. But recently there's been, I guess, impatience with this strategy coming from a number of quarters. And there's been attempts to attack the first branch of this disjunction that Halvorsen has given us. So as Williams puts it in his paper, Scientific Realism Made Effective, the central vice of standard interpretation, illustrated by this quote from Halvorsen, is that it declares essentially all empirically applicable quantum field theories to be unfit for interpretation, right? So shouldn't we be interpreting the theories that people actually use, physicists actually use successfully, rather than waiting until we get some other theories that somehow do the same thing? So question, what is it about standard interpretation that's so bad? What is the problem with it? What feature of it is leading to this problem? Williams gives a list of a couple things. The one that I want to focus on from him is what I'll call isolation. So says Williams, according to the standard approach to interpretation, the theory to be interpreted is assumed to provide a true and exhaustive description of the physical world in all respects, including at all length scales. A theory is to be interpreted in isolation. So these are two different things of the five that Williams points out. But you know, as he points out, and as I think is true, they're all related, these problems. So isolation here is capturing the idea that when you interpret a theory, you interpret that theory and nothing else. And you just sort of assume that that theory is true, end of story. And then go ask, well, if that's true, what else is true? Another distinct complaint, or what I take to be a distinct complaint about the standard hermeneutic approach comes from Laurucci. It's what she terms pristineness. She takes the standard approach to involve an ideal of pristine interpretation. This was mentioned yesterday. Underlying this methodological ideal of pristine interpretation is a distinction between what holds at each world of which a theory T is true and what varies. And to adhere to the ideal of pristine interpretation is to invoke only considerations from the former class when circumscribing the collection of worlds that are possible. That is, to focus only on what holds at all worlds or no worlds. Don't look at contexts of worlds. So what I'd like to do today is give a qualified defense of isolation that's compatible with a rejection of pristineness, and in particular is compatible with Rucci's notion of locoveracity. And I'm drawing most of this from a forthcoming article about Wilfrid Sellars' influence on the development of constructive empiricism. So this is the pragmatism connection via Wilfrid Sellars. So if you'd like more, you can go look at that. So Williams expresses, let's say, bafflement in his article that people think this is a good idea, the standard hermeneutic. He lists rather starkly the assumptions that go into it. When looking at them, they seem a little peculiar. He says the goal of his article is to argue that they are at best unmotivated and at worst, I don't quite remember, but it's quite bad. And so the question that this prompts for me is, well, why are we doing this, right? Why would anybody ever think this is a good idea? Are they really so unmotivated? And it seems to me that the natural way to answer a question about motivation is to look at the historical development of these, right? So it does seem to me to be the case that many philosophers of physics in this particular tradition do use broadly similar interpretive moves. Why? And I think if you do a little bit of reading around the kind of people who have talked about this, and there's not too many, but one thing you quickly run into is a certain historical story about how we got to the kind of interpretive game that we're doing now. And it goes something like the following. We assign content to theories so that we can be selectively realist. We would like to be realist about our scientific theories, but for various reasons we think we can't be just like full in, I believe everything that says down to the last letter. And so we need some way to say, well, the theory says thus and so, but I only want to believe thus. And if we want to do this, then there has to be some sense in which the theory is saying something even though we aren't, right? And I'm gonna keep saying that the theory says, even though I don't mean and don't think we need to commit to anything strong about propositional structure or so. Okay, why do we want to be selectively realist like this? Well, because what is the realism debate? Well, it's an epistemological debate. It's a debate against the great anti-realist threat of, say, Hesse's principle of no privilege, or the pessimistic meta-induction, or criticisms of IBE, like we saw yesterday, or from, say, Van Frossen. And why is the greatest threat epistemic? Well, because the other natural threats, semantic threats, we defeated them in the 60s, right? With the fall of logical empiricism, this sort of semantic kinds of instrumentalist, anti-realist are a no-go. But I think if you go back and read some of the stuff from the 60s and 70s, the picture's a little more complicated than this. In particular, I think you can draw out of it at least two, really more, but at least two different kinds of realism that both count as semantic realism in the sense that people talk about today, but disagree in the details. So one sort of flavor of realism along these lines is the kind of epistemic realism that the selective realists are engaged in a debate over. This is one that I take to be associated with a sort of Aquinean or Putnamian tradition. And the general picture here is that, well, we've got this uniform referentialist semantics. Realism means inclusion in our theory. So to be is to be the value of a bound variable. What do we think exists? Well, whatever we bind with existential quantifiers. And so now the game is, well, okay, what ought we to include in our theory? And this is an epistemic kind of question. But there's a second kind of realism, which self-consciously takes itself to be opposed to the first, and vice versa, which is a more kind of semantic, still kind of anti-realism. And here I'm going to associate this with Wilfrid Sellars. And the picture here is that, well, there's this variegated functionalist semantics. Different domains, different vocabularies have different semantics to them. But it's not the formal semantics, but rather, say, the meta-semantics, if you like. This is a distinction drawn in various ways. I'm probably just going to say formal versus philosophical semantics. For this picture of realism, what it is to be realist about some discourse is for the function of that discourse to be relevantly similar to the function of our everyday description and observation discourse. And so in particular, when Sellars wants to argue for scientific realism, the way he does it is to try to show that the function of theoretical talk is indistinguishable from the function of descriptive talk, and that it's in fact continuous with it, and in fact we can only make sense of the practice of science if we believe that in some sense theoretical talk has already replaced our observational talk. What makes both of these approaches realist is that they're not instrumentalist, right? So this is just sort of a terminological issue. There are two sort of interpretive strategies in the terminology of, say, Feigl 54. There's two kinds of interpretations. There's realist, there's instrumentalist. These are realist interpretations because they're not instrumentalist interpretations. Nevertheless, I think there's a sense in which they're realist in different ways. And certainly they took themselves to be, right? So Putnam is quite clear he thinks Sellars is not a realist because he's not sufficiently referentialist. And Sellars thinks Putnam is sort of dangerously flat-footed about what he says semantically. So, okay, so, but what's the cash value of this? Well, this is really where the pragmatist connection comes as well, right? So when today pragmatists talk about being interested in Sellars, this is the reason that they're interested. Because Sellars uses a certain kind of move over and over again. to try to give ultimately anti-realist analyses of various domains or vocabularies, which he nevertheless wants to give a kind of uniform grammatical treatment in the way that Tushar was talking about 2 days ago. So very briefly, here are 3 examples. Sellers' PhD, his initial idea for a PhD project was to develop a version of a sort of plan expressivism. William Frankena got there first, so he tried to do a Kant one instead and never finished. Nevertheless, later when he got around to working on a moral theory, he developed this version of moral expressivism, where moral judgments express what he calls we intentions. These are sort of the intentions of the group of which I'm part. And this involves a sort of grammar of a shall operator, right? And so there's a kind of formal logical question you can ask here about what is the grammar of the shall operator. In one of his papers, Sellers develops a grammar here that's motivated by what he takes the sort of pragmatic function of moral talk to be. But the thing that he's doing here is to say, look, moral talk embeds just like all other kinds of talk. It's wrong to lie. If it's wrong to lie, if something's wrong, it's wrong to get your brother to do it. Therefore, it's wrong to get your brother to lie. That kind of thing, Sellers says, we need to be able to capture. This is just a feature of our moral talk. Nevertheless, that doesn't mean we need to be realists in a kind of boring way. We can try to have this more substantial story to tell about the function of moral discourse. The reason that philosophy of science, this makes a difference in philosophy of science, comes mostly from his treatment of modality. So again, he says modal judgments express something. What do they express? They express rules of inference. They have a particular grammar. This is a grammar that he cashes out in terms of a possible worlds analysis. What is the difference between a contingent and a necessary implication for Sellers? Well, it's that we do different things with them. There's no formal semantic difference between the two. They play different roles in our theorizing. And as such, we should look to context, we should look to pragmatics to understand the role of modality. And he uses this to explain certain formal features of subjunctive conditionals that Goodman and Chisholm had pointed out. Okay, so the general picture here, I'm going to skip the semantics ones for time. The general picture here I think is pretty clearly expressed in this blog post that Ben Frossen wrote about Sellers recently, where he says the kind of move that Sellers is pulling has 2 stages. The first stage is to give a realist account, and in the second stage, the first is aufgehoben in a way that Sellers saw as the completion of Kant's Copernican revolution. People tend to get very fancy in the way to talk about Sellers. But right, I just wanted to put this up here because is this realist? Well, it's realist in a way because we have this kind of uniform formal semantic treatment, uniform grammar across them. But there's, I think, also an important way in which this is not realist. It's pragmatist and it's context dependent. So, okay, if this is a version of realism that seems compatible with what has actually been established in previous debates about realism, then what should we say about mathematics? Well, I think, unfortunately, the answer is too complicated to fit in this talk, and so I'm only going to indicate some things. I want to indicate 3 things. First, I think that the rise of the semantic view, the so-called semantic view of theories, complicated things in the sense that in throwing out some of the very nuanced, perhaps overcomplicated syntactic treatments of scientific theories, we then sort of went back and got too simple with it, right? And this is something that Ben Frossen has also expressed in his 2008 book, Scientific Representation, that he was a little bit too sanguine about the ability to talk about, say, isomorphism between mathematical structures in the world. So this is a sort of contingent, I think, coincidence that this sort of thing happened. Why haven't we worried about this too much explicitly? Well, because there's this old assumption that we can tell the same sort of story about mathematical representation that we tell about linguistic representation. And I think that people are pretty explicit about this throughout the history of this debate, and you can go find it in, say, the Lvov-Warsaw School as some of the, I think, most explicit statements of this. But it's still preserved today in various ways. So I think, when Rucci talks about what is the goal of a standard interpretation, well, it's to produce a specification of the theory's content. What is a specification of the theory's content? It's a specification of the worlds according to the theory and interpretation of these worlds as physical. What are the worlds? Well, they're models in a logician sense. Why would they be models in a logician sense? Well, because then we can tell the same sort of story about in mathematical representation that we would tell in linguistic representation. What stops us from doing this, right? Set theory is a great foundation. Just plug everything in there and we've got models in logician sense. There's also, I think, a second complication coming from work in Foundations of Space-Time Physics, and the sort of framework developed by Michael Friedman that I'll also skip for time reasons. Third reason that there's not been too much explicit discussion about the fine details of mathematical representation is that at the same time that we were getting all these other shifts, a new challenge arose. So I mentioned Sellers had this analysis of modality in terms of necessary conditionals. We don't believe that's a good formalism for subjunctive conditionals anymore. We now do possible world types analyses, right? We do sort of Stalnick or Lewis semantic treatment of at least some of the context. And so at least some of the stuff that Sellers was doing with his pragmatic theory was keeping track of context, which is now included in the formal semantics when we do this in terms of possible worlds. As an aside, of course, the cutting edge people don't do Stalnick or Lewis anymore either. They do interventionist analyses, but that hasn't made it to QFT yet. So hopefully one day. So what should we take away from this, or what do I want to take away from this? Well, what I want to say is that the kind of picture that Williams charges the standard interpreter with is in some sense accurate, but in some sense is an oversimplification. But it's an oversimplification that was kind of intentional and had a reason. So the rise of realism was based on realism about semantics, which I hope to have indicated to you is a slippery notion and changes depending on sort of what exact context we're in, whether our enemy is the instrumentalist or whether our enemy is, say, Van Frossen. Because the rise of realism is based on this realism about semantics, we want to say, well, the book has been closed on the sort of semantic debates, so we don't need to be too complicated about that, right? Let's focus on other stuff, thanks, and not worry too much about how the semantic story is actually supposed to go. Instead, we want to go look at this sort of epistemological question: what do we believe in? What do we not? What sort of, is belief even the right kind of attitude to have, or should it be, I don't know, some notion of acceptance? Because we're now focused on this epistemological question, talking about nuance and semantics is kind of a distraction. That's the right thing to say to people saying, oh, no, but it's more complicated because depending on what context you're in, you're going to have different sets of laws and so forth is, well, yes, that's true, but is it relevant? And one particular reason, sort of historically speaking, that it wasn't ending up relevant is that there were these big picture pressing problems about how to deal with the new modal logic in mathematized scientific theories, which unfortunately became sort of intractable because there are also these open questions in logic about how to deal with quantified modal logic. And so when philosophers of physics then tried to enter, how do we reconcile quantification with modality with mathematized scientific theories, you end up with the whole argument, which is a disaster. I contribute to it too, so right, but so if we have this picture about how we got here with the kind of oversimplification of the sort of hermeneutic project that we're engaged in, what should we say about the complaints that I put up at the beginning from Williams and Rucci? Well, of course, they're well taken, both. However, I think in response to Williams, at least, there is some kind of story about how we ended up thinking isolation is a useful kind of thing to have in certain kinds of contexts. In particular, I think it's defensible insofar as, and to the extent that it's required for semantic realism in the sense of thinking that theories say X, Y, and Z, and we want to decide what things do we want to believe of those, right? So there needs to be some sort of external notion of content that we can assign to a theory. And insofar as we can assign content to a theory, that's going to have to be, to some degree, isolated. But the thing that we should say is, it needs to be to some degree isolated. How isolated need it be? And what exactly are we going to be doing with this content? So, there are going to be, I think, especially at some of the more controversial edges of, say, modal space, it seems fine to me to say, yes, I like isolation in general. Here's a case where I think there's just no fact of the matter about, whether this space-time is reasonable or not, for example. I think the second thing, so that's what to say about isolation. What to say about pristineness, I think the thing to say here is it's just right. The simplification of fine detail was a starting point. Maybe we got distracted. Maybe we didn't realize it was a simplification. But it's just, I think, true that pristineness is a bad thing to do. It's also true that people do it. We shouldn't do it. So Rucci is right about this. And I think local veracity is exactly the right way to go, right? So it's exactly sensitivity, to what are we doing with this kind of content? Well, it's the kind of thing that we ought to be doing in these more narrow cases. So let me wrap up very briefly. Philosophers of QFT have been increasingly worried about the rules of the interpretive game that they're playing. And I think that looking to the history of the debate can help to disentangle the letter of the rules from the spirit of the rules. And if you like if you want a sort of slogan conclusion, it's hurrah, isolation, and boo, pristineness. So thank you.
Lots of time for questions. I saw Wayne's hand first.
Thank you. This is very interesting. Could you put that slide up with a quote from Porter Williams?
This one or the other one?
The second one, yeah.
Yeah.
Yeah. So there's something really weird about this quote, and people tend to quote this a lot. I see this a lot. Because calling this a standard interpretation suggests that there's lots of people who hold it. And it says, according to standardization, the theory to be interpreted is assumed to be a true and exhaustive description of the physical world in all respects, including at all length scales. Now, what's really striking about that is that there never has been, in the history of science, a theory that was even a candidate for an exhaustive description of the physical world in all respects.
Yeah.
And what's kind of weird about the paper is that Porter supports the claim that this is standard by a series of quotes, and they all say, we're trying to understand what the theory, where it would be like if the theory is true. Not one of them even remotely suggests that they want to treat it as exhaustive and description of the world. And yeah, so his attribution of the standard interpretation, is not even remotely supported by any of the quotes. And for a reason, I don't think he could find anyone who read. But this is important because it is actually essential in the interpretation of physical theories that the theory doesn't deal with everything.
That's right.
Right.
Yeah.
And I don't think this is news to anyone.
Yeah.
I don't think it's part of any lay standard view that you have to wait till you have a theory that deals with everything. Mm-hmm. But also, a lot of the quotes do say true. And but I think that we have to ask what they mean. So, not exhaustive. Newton's theory of gravity obviously was not a candidate for something exhaustive because there are other theories besides gravity.
Yeah.
Right? But it tells us lots of true things. Mm-hmm. And what Newton says, we should take it to be true or very nearly true. And I think that in the charitable interpretation of all those quotes that are supposed to be representative of the standard interpretation is when they say true, they mean true or very nearly true. Yeah. And the reason I say that is philosophers of physics have not been silent about non-relativistic quantum mechanics. Yeah. There's a lot of literature on the interpretation of non-relativistic quantum mechanics, and everyone knows it's a low-energy approximation to a relativistic theory.
Yeah. Absolutely. I mean, as Eric Kuehl is wont to remind me, Newtonian physics is impossible because matter couldn't be stable. I mean, this is an overstatement of this is Eric getting over his skis. But I mean, I think.
Well, actually, I don't think there's a, it was an open question.
Good. Yes.
The matter was always an open question in classical theories. I think no one ever thought they had a complete account of what matter was like. Right. But that's but it was always an open question. So it's saying it's impossible is
good. So I mean, I wanted to say two things about the Williams quote. So the first is I think that I just agree with you that it's uncharitable in a way that is useful for what I take him to be wanting to do in the paper, which is to say, well, we all agree that true can't be a very simple thing. true or approximately true. But we need to say something more about it. And what more can we say? And I take his various ways of articulating what his notion of effectiveness to be attempts at doing this. And one reason that I think the thing that he's really trying to capture there is something that came out yesterday in the discussion of Jim's talk, which is it is at least prima facie clearer how to talk about a dependency being restricted to a particular domain, energy scale, whatever you like, whereas it's a bit harder to see what it would mean for, say, pions to exist in an energy scale and not another one. Now, I'm kind of happy to talk this way, but what has emerged from talking to other people, especially this week, is that others are not. And so why wouldn't they be? Well, if I'm Porter, well, here's a way of doing it, because they're worried about sort of existence has to be an exhaustive kind of thing because of the way we talk about existence claims and so forth. So this is one of the things that well, yeah, that's the two things I want to say.
Great. Laura.
Thanks. I agree with Wayne about the quotes are from my hero, my dissertation advisor, one of my dissertation advisees, myself, one of my oldest friends.
Are they all the same person?
And yeah, then he spells out the properties of standard interpretation. They feel like they're accreting a lot of things that were incidental to the kind of basic idea shared by the quotes. Sorry, that was a self-indulgent aside. Boo isolation. So with respect to spelling out the content of the theory, the interpretation, boo isolation.
Okay.
But do you think it has a role to play in evaluating interpretations? Like think about this storied history of interpreting non-realistic quantum mechanics, considering it, it's considering interpretations as candidates for describing a world in which relativity is also true. Seems like it's been a really motivated.
Good. Actually, sorry, I wanted to say hurrah isolation myself.
Yeah, I know.
Oh, you were saying boo.
No,
Okay.
No, yeah, maybe that's what I was doing.
Gotcha.
Hurrah isolation.
Yeah.
I'm making a case that at the phase where we're evaluating interpretations for isolation being not emergent. Yeah.
Right, but sorry, so you were saying it's not good, but do I think it has a role to play sometimes? Well, yes, I think it does have a role to play in many of these cases, most of the time.
And then do you think it's sneaky or cheating to look towards the evaluative stage of interpretations and try to construct interpretations that are going to satisfy the consistency constraint that they play along other theories we want to interpret?
No, I don't think that's cheating. And the reason that I don't think it's cheating is that I think that it's a vast oversimplification to think that we have anything like a systematic story about the grammar of this, that, or the other. I mean, we use examples like if then and so, but even if then is kind of a mess, right? And so I think it's clear that if we have this idea that there is some sort of theoretical content that isn't just whatever I said, which it seems like we need to have if we want to think that the theory is going to be consistent, because unfortunately I'm not, then there needs to be some story about how we get that. And I think it's, if you look at the history, just not at all clear. In most cases, like we don't realize what the content was, right? So I'm thinking here of, say, the reception of Maxwell electrodynamics, right? Maxwell certainly seemed to think that he was capturing Faraday's electrotonic state. It was clear that his big three papers, especially his derivation of freestanding electromagnetic waves, had problems. Everybody knew it had problems. Everybody thought, well, what we need to do is we need to figure out what should the theory say. In particular, what should we say about the mechanical properties of the ether? Well, now we realize that was the wrong question. And we should say it was always the wrong question, because we shouldn't have thought that there was, the theory didn't say that there was an ether in the first place. But we didn't realize that. And I think that, there's a similar story one could tell about the Aharonov-Bohm effect. Porter takes Balot to task in this paper for doing this kind of thing for the Aharonov-Bohm effect. I think this is the kind of response that ought to be given. I think Balot says something. I think this is the kind of thing that could be said in that case as well. So these are both electromagnetic cases, but that's just because that's what I've thought more about. It seems to me it could be reduplicated.
Okay, so we have time for one more question, and I have two hands. So it's Carlo and Mike, if you want to
Fight over.
Two politest guys in the room.
It's a Canadian standoff, so I guess we'll go with Carlo.
This is maybe fast, I'm not sure.
Yeah.
First, I thank you very much. That was very enlightening for me, and I found it very convincing to say. My question is specifics about quantum field theory, because you sort of mentioned quantum field theory as a motivation for you. You didn't go into it. But I never understood what are the troubles of quantum field theory and what are philosophers warning about quantum field theory for this reason. I mean, of course, quantum field theory has trouble. We know mathematical trouble. That's not the point. And the reason is the following. There's a way of describing sort of quantum physics by saying, oh, there is no relativistic quantum mechanics, a particle with a no relativistic Hamiltonian. And then there is something which is relativistic, which is quantum field theory, which is a very bad way of thinking about that. So that's not the actual situation in which we are. That situation in which we are, there is a very precise mathematical formalism for quantum theory in general, okay, which has subcases when the Hamiltonian is a no-relativistic particle or a non-relativistic particle, then another case in which the Hamiltonian is Hamiltonian quantum field theory. The Hilbert space happened to be a Fock space, that structure, and the Hamiltonian is the one given by the Poincare invariance. Now, once this is clear, it seems to me that most, not all, because some are technical things, but most of the funny interpretative problem of quantum field theory are just the standard problem of quantum mechanics read in the context of one particular theory, and thought that were new because quantum field theory seems simpler than quantum mechanics, but it's not. And if the discussion about quantum mechanics interpretation has nothing to do with non-relativistic quantum mechanics, it's just a discussion about quantum mechanics, about perhaps locality and things like that. So whatever stance you take with respect to quantum mechanics, you do Bohr, there is a classical volt, blah blah, you do Bohmian, you do many volt, you do relational quantum mechanics, whatever you do, you take it, you bring it to quantum field theory, and all except some technical aspect, the problem of quantum field theory disappeared. Totally. Of course, it remains all the problem of the interpretations you picked, which is disliked by always 75% of the rest of the community. But that's a problem. I don't see what specifically in quantum field theory which is particularly worrisome from the point of view of interpretation.
Good. So I guess it's the things that you were waving off as technical problems. So in particular, I'm thinking of, okay, so the perturbative series are all non-convergent. That's fine. We know how to deal with asymptotic series. Unfortunately, we also have, say, renormal singularities. How do we deal with renormal singularities? Well, we choose a different contour about which to integrate. Which contour do we choose? Well, is this something that the theory can give us, or is it something the theory can't give us? What's the relationship between this perturbative series and the existence of? We would love to have sort of a Hilbert space representation of this theory. Why do we think that it exists? Well, one reason you could think it exists is that you have faith in quantum mechanics. But it's hard to know what to do with faith. And so what we want is we want to be able to say that there is a kind of non-perturbative thing that the perturbative theory is an expansion with respect to which. And one way, so I mean, that's the short answer, is that it's these technical worries in particular that are worrying people here. And I think one sign that this is really what's worrying people is that, somewhat shockingly, the philosophy of quantum field theory literature doesn't talk about interpretations of quantum mechanics, and they don't talk about the measurement problem. And I don't want to do that either. So, but it's not clear how long we can keep doing this. Yeah.
Great. So let's thank John again.